Good evening, good afternoon, good morning, wherever you are. This is Olaf Monien from Developer Experts. I'm a Embarcadero MVP, and this afternoon I'm gonna demonstrate something about using Apple's Touch ID. Apple's Touch ID is a specific technology that can be used, well, the name already says it, by Apple devices. So this skill sprint is about mobile development and iOS devices in specific. So there is nothing for Androids here, it's just iOS devices. All right, again, my name is Olaf Monien and I'm Embarcadero MVP. My email address is on this slide as well, so if you have questions that you cannot get answered during the closing Q&A session, then just send me an email and I'll try to answer whatever you have. All right, this is about Touch ID and a framework that Apple provides to well, use fingerprints in your applications. This is just for iOS, it's for Delphi and C++. We will have a C++ session later on, and well, it's just a short skill sprint to demonstrate how that actually works. All right, let's get rid of that one here. Okay, so usually we have applications that are, well, protected by passwords. For the purpose of this demonstration, I created a simple application that I call Secret Notes. So it's an application that you can use to track notes of yours and protect them with a password. This is something we have done for years with Delphi applications. So if your application is something that you want to protect, then you would have a password. You can verify or authenticate your user with a username, a password, whatever. On Windows desktop applications, this is basically what we've done all the time. Now with mobile devices, passwords or entering passwords has become a little bit, well, I really don't like to say tedious or nasty or whatever, but on those tiny devices, entering passwords is something I really don't want to do all the time. And well, the idea that Apple came up with is well, integrating fingerprint sensors in iPhones and iPads. So to unlock an iPhone or an iPad, you can use your fingerprint sensor on the iPhone or iPad. Now, the next step is to use the same technology to unlock your own application by presenting the user an interface to, well, hold his finger on the fingerprint sensor. This whole technology is called Touch ID. So fingerprints are identified or used as an identifier for a user. This user that we are going to use, or that is basically applying his fingerprint, is what we call, or what Apple calls, the device owner. So for now, there is just a device owner that authenticates by entering or applying his fingerprint. To use that information, if the user holding that device and entering or applying his fingerprint, and to get the information if that user is a legit user of the device or of your application, we are going to use a local authentication framework. This local authentication framework is a framework provided by Apple. So again, this technology that I'm presenting here is only for Apple devices, for iPads and iPhones. So the local authentication framework basically provides just a single information. When the user enters his fingerprint, the framework will tell us if that fingerprint belongs to the device owner. That's all the framework does. And to basically use that in Delphi, we need a Delphi wrapper. All right. So that's all I have on the slides. And the next thing is to see the whole stuff in basically in a demonstration. First, before we enter the demonstration, just let's see what we have as resources. The first thing is the local authentication framework reference by Apple. The URLs are actually in the slides, so you don't have to record or write them down here. This is the whole documentation about the local authentication framework. It provides basically just one class, that's the LL context class, and that class we are going to use in Delphi. There are two methods that I will explain later on. And to use frameworks which are currently not in the box, we need a way to wrap them into our Delphi environment. So in other words, the local authentication framework is currently not shipped by Embarcadero or Idera with Delphi. So we need our own wrapper. I could have written my own wrapper, but luckily I found somebody who already provided a wrapper, and I'm going to use that one. It's basically like writing header files for C++ APIs, so it's very similar to that. This Bitbucket URL basically provides all the files you would need to use that in Delphi. All right, so let's go to Delphi now. What I have here is a simple application. This simple application is just an application I call it secret node. So it has a table. I'm just using a FireDuck memory table here. This FireDuck memory table can be stored to a file. I'm just doing that. Of course, we could have used databases. We could have used REST services, whatever. But for the simplicity of that demonstration, I'm just using a simple memory table. The memory table we are using here has just 3 fields: a creation date, a title, and a node itself. So it's very simple structure here, and I bound everything using the visual designers. And let's see what that is. Okay, there are a couple of elements that we just want to hide here, like that one. So it's all visually. Let me hide that one as well. All right, so we have basically our table here: creation date, title, node, and we have a list of nodes, which is a T-list view, and we have an edit for the title and a memo for the nodes. So this is all standard stuff. So here's the memo. Somewhere behind that password screen, there is an edit, and here's the list view. Very simple stuff. And next thing is, when the application starts, we are presenting a login, or basically just a password screen. I really made a very simple application here. So this is a cPanel. It does have an edit for the password and an OK button, which does everything. To get the idea of what this does, let me start that in Windows. So target platform 32-bit Windows. Just let's run that application here. Very simple. Even though we are going to use a technology which is meant to be used on iOS devices only, for design purposes, you still can run and try everything on Windows, on the Windows target. Let me see, I broke something here. All right, I broke that one here. It's all prepared already, and just let's run it again. Okay, here we go. So the application starts off, and very simple stuff. Before you can see any nodes, before you actually can go into the application, you have to enter an unknown password. Of course, you can make it much more nice than I have it here, but in that case, I just enter secret as a password, hit the OK button, and here you see there are a couple of nodes already. I can enter new nodes, some new stuff here, and I created the application in a way that it saves everything while typing, so it's not a save button or something. It's made to work in a very similar way that you are used to use from mobile devices. So when I close that application, have taken here, it is the password again, enter, and you see Note 4 is here again. So let's have a look at the code now. In that case, I'm using the documents path, and the file name is notes.json. So obviously, I'm going to store everything in a JSON format. This is a little nice feature in FireDuck memory tables. It can use JSON, so we want to be modern here. For handling application events, the application is created in a way on an iOS device. When I send it to the background and get it back from the background, it will ask for the password again. That's something I have to use, or I have to use application events for. We will see that later on. Okay, the next thing in the startup mechanism is you're locking the nodes, which means, well, basically display the password screen and close the nodes table. So in the case the nodes were actually already open, close them down so that the user cannot access nodes until he has authenticated by entering a password. So instead of asking for a password here, I'm requesting Touch ID. I'm requesting a Touch ID. So let's see what happens. Into the simple password handling, the user entered is secret. Well, of course, simple demonstration here. And in the case it's the right password, we do unlock the nodes. Unlocking nodes means load the table with the nodes and hide the password panel. If the user entered the wrong password, well, we're just showing a message and set the focus again on the password edit. So this is traditional stuff. Now you have seen that we actually request a Touch ID here. So requesting a Touch ID is handled down here, defines here, conditional defines to make sure that this stuff is only executed on iOS devices. Remember, the fingerprint sensor is only available on the actual device. It doesn't work in the simulator even. So you really need to run this on your device and not on the simulator. This is the reason why I'm not checking for iOS only, but also for CPU ARM, which means we are really running on the device here. The code behind wouldn't actually run on the simulator, or it wouldn't compile on the simulator because there are libraries that only are available on the device. All right, so the main thing we need is a context. The LA context is what Apple provides. So we do a traditional alloc and wrap. Looks a little bit weird, but that's standard way how to create iOS operating system objects. So this gives us a L context, a context of the local authentication framework that Apple provides. And once we have that context, we can ask, can you evaluate a policy? So we are just checking, would the fingerprint sensor work? And the only policy that we can check for is device owner authentication with biometrics, which means, well, is the fingerprint that is applied to the device, is that the owner of the device? That's the only policy that Apple currently implements. So is that policy available? That's basically what we are testing for here. Only if that policy, or if we can evaluate that policy, then we continue. Why do we do that check? Well, even if you have a modern or a newer iPhone or iPad with a fingerprint sensor, it might be deactivated. It might be that the user did not enter any fingerprints yet. So we really have to check that it works. And for older devices, it will also tell us, well, there is no working Touch ID. So I'm just storing that Boolean value here, Touch ID works. So if the Touch ID works, then we can actually check for and present a fingerprint dialogue. So this basically shows the fingerprint dialogue on the device. So only, and this procedure does not return true or false. It requires you to enter a callback procedure, which is this one here. So this is a callback, and this callback will be called once the user succeeded in applying his fingerprint to the device. So let's have a look into the callback. This is the callback. And the callback basically will get called by the iOS operating system. We have a success or an error, and an error. So we basically check if there is no error, and when the success is assigned, then let's see if the success is basically a 1. So if success is 1, then the fingerprint that was applied by the user is actually a fingerprint that authenticates the user as a device owner, and that's what we are looking for. So if we have success, then we unlock the nodes. Otherwise, we just say authentication failed and lock the nodes just to make sure that nothing is revealed without intention. And some of you might already have noticed something special here. This is very important. This callback may not come from the main thread. It actually comes from the background thread. So it's very important because we are updating the user interface. Unlock nodes would hide the password dialogue, and lock nodes would actually show the password dialogue, and we might show a message. So we are definitely manipulating the user interface. For that reason, we have to call all this code in the main thread, and thread.synchronize is an easy way combined with a anonymous procedure or method to make sure that all this code in this anonymous method will be called by the main thread. It's very important to do that. If you don't do that, it looks like it works, but it really doesn't. It wouldn't update the user interface in the proper way. You might even receive access violations. All right. Down here is just some simple stuff about how the data is saved. Just, well, we have the memory table nodes, save to file. You can specify JSON format. We save everything after inserting a new node, and after every post, we do a save to file. And we have some keyboard handling for those who are interested. So the keyboard will pop up, and it will actually move the content so that we can really see what we are typing. And down here we have finally some application event handling. So this is the registration or the event handler for application events. I've shown you that in the onCreate of the form. So if the application goes to the background, so the user hit the home button, then we are locking the nodes, which means when we're coming back, which is the will become foreground event, then we should actually request a new touch ID, because otherwise the nodes will be locked. So this is something you might have seen from banking applications or password storing applications like 1Password or so. All the time, or every time you send your application to the back and bring it back up to the front, it will ask for authentication just to make sure that nobody can steal your stuff. That's the idea behind that. All right. So finally, let's see how that works in a live demo. So we are switching back to 32-bit simulator. And before I show that, two things about the wrapper. Let's go up here. So we need those two files. This is the actual wrapper unit. So this is what you get from that Bitbucket URL. This is the wrapper for the local authentication framework. We just use that. And the other thing is, well, make API helpers. We need some helper stuff here. That's fine. The only thing is this unit needs some extra work to actually be able to use that. So we go to Tools, Options, very important. And there you have the SDK Manager. And we are working with iOS device 32 bits in that case. And we have frameworks here, frameworks. And this is what I added. And sometimes this dialog doesn't really store what you see. In my previous attempt to get all this working, I had the framework added and everything, but for some reason it didn't store it properly. So you have to make sure that you really have this entry down here, and to get that entry, you basically mark one of those previous entries here, say new, go here, library, frameworks, and enter local authentication. That's the name of the framework, and make sure that this is all case sensitive, that it's correct. Don't check any of the pass types. Don't check anything here. And hit OK. I don't do that because I already have that. And then you should receive that single entry here. There's one additional step. The step is to go to Project Options. Because we added a custom framework, we have to know the linker that he actually has to use that additional framework. And that way we go to Defi compiler linking, and here we add every framework that we added, well, on the custom way. So just framework with a dash and then local authentication. That's all. That tells the linker to use what we basically entered in that SDK manager. Now we should be able to compile everything. It might take a moment or two, sometimes maybe even 3 moments. It's, of course, depending on the PA server. So I have a Mac in the background, and there's my iPhone connected to the Mac, and I have a PA server running, which is currently deploying all this stuff to my iPhone. And once everything is running, we should be able to see my iPhone on the screen. To actually do that, there should be my reflector active. Takes a minute. Here we go. So if you want to present your iPhone on a screen, you would need a special software. The software is called Reflector 2. You might send me emails about that. Just look up in Google for Reflector 2. Reflector 2 is basically it's a tool that allows you to project iPhones on your Mac. or even on Windows computers. So we see the application started. So it's asking for a Touch ID for secret nodes, and I am now applying my fingerprint. And you have seen the password dialog, which was behind that screen, just went away. I can add a new node. Let's do that, node 4, something. Oops. Here we go, done. And node 4 is still there. And we can move between the nodes. That all works. So I'm just switching. And now I'm hitting the home button. You see the application is somewhere in the background. Hitting the home button again, pulling it up, and you see the Touch ID is re-requested. So every time the application goes to the back and it comes back up to the front, the fingerprint is re-acquired. All right, this is it. Source code will be available shortly on the website. And it's time for question and answers.
Your question here, is it possible to authenticate a user towards an LDAP server authentication server?
Not in the context of Touch ID. So Touch ID only authenticates the user against his own fingerprints. That's all this framework does. If you want to authenticate your application or the user of your authentication against LDAP or a REST service or whatever authentication theme you have, you can of course still do that. LDAP is covered by a couple of Delphi units. There are actually LDAP wrappers, and yes, you can do that, but it's a different topic. It's not related to Touch ID.
Is there any way to use the fingerprint sensor for local application authentication separate from device authentication? For example, use the sensor for multiple people using the app, separate from the authentication stored fingerprints for the device.
I understand the question, and I see where the question is actually going. Of course, it would be nice to have multiple users, multiple different access levels or whatever. But Apple currently, as it is, only has one policy, which is that fingerprint, the fingerprint of the owner. That's all we can do right now. There is not more. So, but the point is, if you look at the actual policy, let me see where the policies are. You see, there is, even though it's just a yes/no decision, you have to supply what policy you want, and only even if just that one policy exists means to me that Apple might be supporting multiple users or whatever in the future, but would be something, this is speculating. This is for the future then.
Okay, so you can only use it through the policy, the framework they're publishing, which only has one policy right now.
Right. There's just one policy. You actually see it more clearly in the Objective-C documentation. There is just device owner with biometrics, which means the owner identified by his fingerprints. That's all the framework does for now.
And what versions of iOS does this work with?
This should work from iOS version 8, and of course you would need a device that is equipped with a fingerprint sensor, of course. You always have to check, like I showed that in code, is there a way to check the policy, and if not, then fall back to a simple password authentication method, or just block the whole application, whatever you want. So it's iOS 8.0 or later. And of course, be aware that the user, even if it's iOS 8 and a newer iPhone or iPad, the user has to enable Touch ID. which is not enabled by standard. So if the user skips that on the initialization of his new device, it wouldn't work. That's the reason why you always have to check the framework. Does it work? Does it not work?
Here's the last question. I guess this isn't for you, but if there's plans to support 3D Touch on iOS, I don't know that that's on the roadmap necessarily, although chances are you probably could support it just like Olaf's showing here with just importing the framework yourself. So I guess that's something maybe for future skill sprint.
Right. As soon as Apple enhances the authentication framework and makes that enhancements public, we could actually use that. We don't have to wait for Embarcadero or Idera to implement that. The only requirement is that the library has, or the framework has to be public. There are still quite some frameworks or libraries that are private, and you still can figure out how private frameworks work, but as soon as you put an application into the App Store or try to do that, Apple will refuse the application because you're using some private stuff. So we always have to wait for Apple to make stuff public.
Yeah, that's one thing I love about Delphi and FireMonkey is that, you know, we have this great high-level abstraction layer that's really easy to work with, but if you need to get down to the APIs in the OS, as soon as they're, like you said, as soon as they're available, you just reach down there, you can grab them, expose them like you're showing here for the local authentication framework, and just use it. So, fantastic. And Lars says, thank you, as always, for understandable demos. So, yes, you do a great job with that. Thank you.
Great. Let's see. Nick's asking, you've compiled for 32-bit iOS. Does this work for 64-bit too? I could say no, but it does. It works.
It does. It works.
You have to have...
I think actually the...
Go ahead, Jim.
I think the first demo he did was the 64-bit. What he did this morning. I can't remember for sure. But yeah, as long as you have a device with thumbprint scanner, which is, what is we decided was 5S.
5S and above, and you have to have iOS 8 or later.
Yep, and then the latest version of the Xcode development tools.
Yep. Oh, Nick's asking, in the way Olaf did it, he didn't disable the forms underneath or hide the forms. It was just there, and you could quickly sort of see something in the background there. And I'm not sure how much of that was Reflector sort of switching its pulling frame by, you know, it pulls frames from the device to put it on the Macintosh. But you can always hide a form, right?
Yeah, exactly. I was just going to say is you could be a whole lot more aggressive about when you hide things versus showing them in when responding to those events.
Yeah, so I mean, it's easy to hide a form or put something else over the top. I mean, all sorts of everything you can do with form handling, you can do, right? Enable,
exactly.
Visible, whatever the properties are. Yep.
So the key now is that you the events about going to the background, coming to the foreground, and being able to trigger that Touch ID dialogue and then respond to that. And so, if you want to turn it purple or delete the text if they get it wrong or whatever, you can do all that stuff. Anything you could do otherwise, just a matter of knowing the events and how to invoke that dialogue and respond to it. So there is a thumbprint API on Android in the Marshmallow release, I believe it was, but it's not. I'm not sure about what devices it's supported on, and if devices that have thumbprint scanners support that API using hardware manufacturer APIs. So it's a little more uncertain still at this point, but I'm guessing probably after a couple of Android releases, we'll probably start to see thumbprint scanners standard on Android devices with that API becoming adopted.
Yep. Okay, Jim, that's it, and everyone, we'll see you all next Tuesday.